Hi, I'm Devon with Math Mentors, and today we're going to be talking about limits. So, the idea of a limit is it's supposed to tell you where on the graph may a point should be even if it's not there. So, let's assume we have an asymptote. Let's assume we have a random asymptote. We have some graph that goes like this, but then suddenly it goes like that. Well, it'll look something like this. And then maybe something like this. Oof. I'm so sorry. Something like that. This is an example of something you would use limits for. Okay. So you can assume here we have this at x equals 2. We have this. So what can we assume here? So this function, we're just going to call this f of x. I'm not sure exactly what the formula of this function may be, but we're just going to say this is f of x. Now, all we know on this function is that when x is equal to 2, f of x does not exist. It is indeterminate. So this is an asymptote, as you were probably likely previously taught, right? So the idea of limits is to tell you where that might end. So as an example, a function like this would not have a limit at 2. And the way to explain that is because if we say the limit as x approaches 2 of f of x, so what can we say? As x approaches 2, going this way, goes up, 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 and it stops. It goes towards infinity, and then it goes right side. It's going from the bottom. It's going up, 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 and then continues. But it's like a gap, you can say. So the limit as x approaches 2 is also does not exist. And the reason is because the way you'd write it is the limit as x approaches 2 minus, and what this minus means is it doesn't mean it's a negative number. It means we're choosing a infinitely small number near on the left side of x equals 2. So it would be a number like x equals 1.99999, repeating. An example of, and I mean this function as x approaches the left side of 2 goes up, and since it approaches all the way up, it never stops. So you would say the limit as x approaches negative 2 of f of x, or x approaches 2, the limit would be infinity. And you can see the same thing here. The limit as x approaches 2 positive of f of x approaches, and if you're saying it's approaching the right side, you're going the opposite direction. So you're going down infinitely. So it's going towards negative infinity. Negative infinity. That's good enough. Why is there no limit then? Because for there to be a limit, the limit as the left and right side approach a certain number as x approaches it, these have to be equal. They are not equal because they're going in completely opposite directions. One's negative infinity, one's positive infinity, which means they're not equal. Since they're not equal, the limit does not exist. Now, to create an example where the limit may exist would be something along the lines of, if I can erase this real quick. Let's say we just have a normal line. Then all of a sudden, as like something you might see in a piecewise function, there's a hole. It's kind of hard to see. Let's assume there's a hole here. Line goes down like that, but then it keeps going. So what this is we have a hole at x equals 4. It's f of x. So if we have a hole at x equals 4, if we're like by the rules of the function, as we go along this function, there is no value here. F of x is at f of 4 does not exist. But even though f of 4 doesn't exist, the limit as x approaches 4 of f of x equals 4. And that's because you can see as this function is approaching 4, it's also approaching 4 on the y-axis. And you can prove that by saying the limit as x approaches 4 minus of f of x equals 4. Because remember, this is an infinitely lengthening number of like 3.9999, just barely not equal to 4. Just smaller, just a bit. And that will tell you this will be equal to a number equally close to 4. And you notice the same thing when you do the limit as x approaches 4 positive of f of x. It's the same idea. You're picking a number something like 4.00000001. Like just at the end, after hundreds and hundreds of zeros, you have a 1. And it's going to be some number infinitely close to 4, which means the limit is 4. And now since these two limits on the two sides of x equals 4 are equal, that means the limit, since these two, since they are equal, the limit as x approaches 4 of f of x equals 4. So I hope this helped give you a little bit of a better understanding on limits, and I hope you have a good day.